The mathematical symbol of today is the so-called gamma function, written with a capital gamma. And the name of the variable we put in is usually given by z. Now, the explicit definition of the gamma function is not so simple because it's given by an integral. Indeed, we integrate from 0 to infinity. And the variable for the integration is given by x. And the number z from the left-hand side we find here in the exponent of x, because it's x to the power z minus 1. Moreover, this is then multiplied with e to the power minus x. So you see, this is not a simple definition for a function, and to make it even more complicated, I can tell you this z could even be a complex number. However, then we need that the real part of z is positive. Now this means it's allowed to put in, for example, natural numbers. And indeed, there we find a nice property for gamma of n. Because one can show this is exactly n minus 1 factorial. Or in other words, the gamma function is a generalization for the factorial. And exactly this gets even more apparent when we prove a similar recursive formula, which reads like gamma of z plus 1 is equal to z times gamma of z. Of course, the gamma function has also other nice properties we can discuss in another video. However, now you already know what the definition of the gamma function is. So, if this was helpful, then I see you next time.